Thank you so much for joining me. In this video, I'm going to be looking at the mathematics involved in heating and cooling curves. So I always draw this as a heating curve. The cooling curve would be the opposite. So there's 5 possible segments. We can heat a solid, we can melt a solid, we can heat a liquid, we can vaporize a liquid, and we can heat a gas. Now, the mathematics involved in that, there are 2 types of mathematics that we can have here. Okay, so I'm going to draw segments like this because each of these would be a separate math step. Okay, and each one has its own formula associated with it. So let's take a look at that and label our axes. So temperature would be the y-axis. My first plateau is my melting or freezing point. My second plateau, this is my plateau here, is my boiling point. Now, whenever I have, this is Q1, I'm just going to number them, Q2, Q3, Q4, and Q5. So there's 5 segments. My total, if I had a full 5 segment calculation, my total would be the heat from step 1 plus the heat from step 2 plus the heat from step 3 plus the heat from step 4, and I think you've got it. Now, the main difference is if we're heating the substance, all of our Q's are positive. If we're cooling it, all of our Q's are negative. Now, if there's a temperature change, the formula that you use is Q is equal to the mass times the specific heat capacity times the change in temperature. So every time there's a temperature change, you use the same formula. Now the values you plug in, your heat capacity, your changes in temperature would be different, but the process would be the same. Now, if there is no if we're on a plateau here, that means there's a phase change. So in this case, Q is going to equal our mass times our delta H of fusion. And here Q is going to equal our mass times our delta H of vaporization. So those are the 2 formulas that we use. The main challenge might be is in checking your signs. Make sure all of the signs are either positive or negative. You're not going to have a mix of signs if you're doing a Q total. And then you want to check your units. So sometimes you'll get constants in joules, and sometimes you'll get constants in kilojoules. And if we want to add them together, they have to be in the same unit. So that is kind of the big picture of the type of calculation we'll be doing. So let's take a look at one. So in B, all of these are dealing with, this is just a 2-step problem laid out for us. Both of them have 125 kilograms of liquid bromine, okay? And then we're just going to add the steps together. So instead of having 5 full steps, I'm going to demonstrate it with 2 steps. So you notice we have a temperature change and we're given a heat capacity. So we know that we get to use MCAT. So Q is my mass in grams. I would expect you, if you were one of my students, to show me the work to get from kilograms to grams. For the sake of speed in this video, I'm going to go ahead and convert that. Times your heat capacity, MCAT, mass, heat capacity, times your change in temperature. It's always your final minus your initial. So minus 7 minus 55. And I'm going to go ahead and keep a few sig figs till the very end. But technically it should, I guess I'll go ahead and round it. 1.78 times 10 to the 6 joules. Okay, always double check my math. It's been a long day, kiddos. Hate to lead you astray. All right, now we're going to freeze it. We're at a phase change. So this time Q is going to equal our mass, and it has to be in grams. So 125,000 times my delta H of fusion. And freezing, if you ask yourself, if I put it on the stove, would it help? That answer is a big fat no, so I know that's going to be negative. And I got 6.88 times 10 to the third kilojoules. All right? So now the question is, what if we did both processes? So if I could sketch this out, we've got down, over, down, over, down, right? It first asked us to change the temperature of the liquid, so we did a little bit of that line segment, and then it asked us to freeze it. So we did 2 line segments. Sometimes if you sketch it out like this, that can help. We did 2 line segments, now we're going to add them together. So Q total, well, let's watch the issues that I mentioned, your units and your signs. Those are both negative, so that's good, but one of these is joules and one of those is kilojoules. This doesn't tell you, this question doesn't specify whether to use joules or kilojoules. So for me in particular as an educator, I would accept either as long as your number agreed with the units you used. So I'm going to use kilojoules, so I'm going to change that one to kilojoules. So that's minus 1.78 times 10 to the third kilojoules. If you were my student, I'd expect you to show me that work, in large part so I can get you some partial credit. And now we're going to add the other heat, which is a minus 6.88 times 10 to the third kilojoules. So the total for both processes is minus 8.66 times 10 to the third kilojoules. Don't forget your units and watch your sig figs. And as always, thanks for joining me.